Hello, this is Mr. Lehman, and today we're going to talk about properties of metals, metalloids, and nonmetals, and their location on the periodic table. Alright, so we're looking at page 4 in our notes today. First thing we want to do is fill out this T-chart, properties of metals, properties of nonmetals, and compare, how they're different, because we're going to do our properties of metals versus nonmetals lab, and we need to know, well, what are the properties of metals and what are the properties of nonmetals? Otherwise, we won't be able to figure out if the material is a metal or not. So, in your notes, page 4, we see 13 different things we want to label. So the first one is good conductor of heat and electricity, and then number 2 is the opposite of that, poor conductor, which is basically a good insulator. So hopefully you know the speaker wires, electrical wires are typically made out of copper, and copper is a metal, and so we can basically write in number 1 here. Metals are good conductors. And I'm not going to write every single word here, but if you want to fill it out, you can pause and do that. And then nonmetals are poor conductors of electricity and heat. Now let's also think about this. If you want to cook some food at home, what do you use? Do you use a nonmetal, like a wooden pan or a plastic pan? That would be a terrible idea. We use a metal pan, a metal pot, because those pots heat up very quickly. A metal spoon heats up very quickly, and it's better for cooking your food. Cook your food faster. Now, spoons, if you're stirring food, a lot of spoons and things like that for cooking will be made out of wood, because we don't want the spoon to get really, really hot, otherwise you burn yourself. You're stirring some soup or making something on the stove. You're probably using a plastic, ideally a wood spoon. It's not real good to heat up plastic because it can leach chemicals, and that's why you don't want to put plastic in the microwave. Plastics get warm, chemicals from the plastic get into your food, and potentially it could cause cancer. Alright, so lower density, higher density. I put a little asterisk here. This is just a general thing, and the general thing is that metals tend to have higher densities. Not true for all, but in general, metals will have a higher density than nonmetals. But like sodium metal, we saw floats in that demo. Sodium will float on water, so sodium's a metal. So like I said, these are not always true, but generally speaking, they are. Nonmetals typically will have lower density values. That's 5. And 6, react with acids. Metals react very well with acids. So if you take a chunk of metal, you throw it into a big vat of acid, you're going to see lots of bubbling and fizzing. Now, not all metals react well with acids. Things like gold, things like silver, and platinum, those are very stable, unreactive metals. So it would take a very, very strong acid to get those metals to react, something like nitric acid. Alright, and we see nonmetals, things like plastic, things like glass. The general rule is they do not react with acids. Alright, 7 and 8. What would happen if you hit it with a hammer? I got a slide here. Malleability. So if we take a piece of metal and we whack with a hammer, metals, with their bonding, metals are able to be flattened without breaking. Gold is an excellent malleable metal. So gold can be flattened to a very, very thin sheet. On the other hand, if we take a hammer and whack a nonmetal, nonmetals are brittle. So I'm going to write for number 7. Nonmetals are brittle. Hit them with a hammer, they're going to break into a bunch of different pieces. And number 8 here, metals are malleable. And we'll learn next unit, unit 6, our chemical bonding unit. We'll learn about that, why that's true. Alright, so we can hit with a hammer, see what happens. If it shatters, you know it's probably a nonmetal. And if it doesn't shatter, if it flattens, it's a metal. Alright, number 9, ductile. Metals are ductile. What does that mean? That means I can take a piece of metal and I could stretch it into a thin piece of wire. Think of a piece of bubble gum. I take a piece of bubble gum and I stretch it. It'll keep getting thinner and thinner and thinner. Eventually it's going to break, but I can stretch my gum into a thinner piece. Well, metals are like that. If you have enough force, you can stretch a metal into a wire. And we got 4 more left here. 10, metallic luster. So luster, how light shines how it reflects from the surface, I should say. Metals have that metallic luster, so think doorknobs, think sinks, faucets, think rings. Metals have that characteristic recognizable shine, and we tend to say that non-metals have a dull or like a glassy, maybe a silky, earthy luster. So it can vary. So by looking at how light reflects from the surface, that's an excellent way to figure out if something is metallic, metal-like, or non-metallic. And then 12 and 13, what we see is that metals tend to lose electrons. So to become stable, metals tend to lose 1, 2, or 3, sometimes even 4 valence electrons. And we'll learn more about this next unit, chemical bonding unit as well. And we'll learn a little bit about this unit when we look at ionization energy. Non-metals tend to gain 1, 2, or 3 electrons to become stable. All right, so non-metals are excellent at stealing electrons, and metals are excellent at losing electrons. So those are some properties of metals and non-metals. And here, if we look at the main group elements, check this out. So here's our group 1. So remember, main group elements, you get the S block, groups 1 and group 2. Now look, everything in group 1 has 1 valence electron. Everything in group 2 has 2 valence electrons. Everything in group 13 has 3 valence electrons. And as we go left to right, 14, 15, 16, 17, 18, look, 4 valence electrons, 5, 6, 7, 8, except for helium. Remember, helium's the exception to the rule. Helium only has 2 valence electrons, but because it only has 1 shell of electrons that can only hold 2 electrons, that makes it act like a set of 8 in an octet. So we'll learn more about why the rule of 8, the octet rule, is very important in this unit. And then metalloids. So the question is, what are metalloids? In our lab today, we're going to have at least one material that's a metalloid. And so your job is to figure out which material is a metalloid. Now, on our periodic table, we can label the stairs, right? The stairs, we see this darker blue line zigging and zagging down through. That separates the left side of the table. To the left of the staircase line, essentially, are your metals. And to the right of your staircase line are where your nonmetals are found. Now, the exception to the rule is hydrogen, right? Hydrogen is a nonmetal, it's a gas, but because it only has 1 valence electron, it acts more like these, chemically speaking, reactivity-wise, than it does the elements over here. So hydrogen loves to lose 1 electron. Also, hydrogen typically will share its electron too, depending on what it's bonding with. But metals are to the left, nonmetals are to the right. Now, our staircase line, which separates the left side from the right side, pretty much every element except for aluminum that is sharing a border with it is a metalloid. So boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and acetine. These are your metalloids. Now look, there's 8 of them. Aluminum is a metal. Aluminum has all metallic properties. So what does it mean to be a metalloid? These are basically called semi-metals. So they have properties of both metals and nonmetals. So if we go back to our T-chart, if a chemical is a metalloid, it's going to have some properties of metals and it's got some properties of nonmetals. So if it has both the properties of metals and nonmetals, we would classify it as a metalloid, and you would know it's one of these 8 elements. Now these elements at the bottom here, we typically don't classify those because those exist in a lab for milliseconds, nanoseconds on a computer screen. So we don't see these elements out in nature. So we're not going to be able to check out whether they're a metal or non-metal or a metalloid because they're very, very radioactive. They're synthetic and they don't last. They decompose very quickly. All right. So metalloids, letter E, metalloids are elements that have properties of both metals and non-metals. And you should label the metalloids on your periodic table using this image. And then lastly, the main group elements are the elements that we're going to study this unit. So I just want to make sure we're clear what the main group elements are. Those are the S block and the P block. The S block and the P block make up the main group elements. The D block and the F block, those are your transition elements, your transition metals. So in this unit, Unit 5, we're going to study basically the properties and trends of what's found in green. So the green elements, the ones colored in green, are your main group. The blue and the red, D block and the F block, those are your transition metals. And the properties and trends aren't quite as easy to recognize, and there's a lot going on there. So we're studying the main group elements, groups 1 and 2, and 13 through 18. All right, so that's it for today. As far as notes go, we're going to take a look at the lab and do the metals versus nonmetals lab next. All right, have a great day.